In this session, we will discuss hexagon related plane surfaces hexagon. We will discuss how to project the hexagon as plane surface with respect to VP as well as HP based on the condition of the plane surface. First of all, we will see how we can draw the hexagon. And being hexagon, it has 6 sides, 360 degree divided by 6, 60 degree on each side. You fix any one side, okay, the base, all the 6 sides of the base will be equal, okay. Being all the base sides are equal, I can assume 40 mm as the base side. After fixing 40 mm, now you see two corners we obtain. So in this itself, it's clearly shown. This is the one corner and another corner is fixed here. Based on this corner, we can draw another corners by drawing the inclination of particular edge is 60 degree. Okay, you can see here. So I fixed this first corner using this first corner with the same length of the side as 40 mm. We assumed as 40 and 60 degree inclination. Okay. Similarly, you can complete another corner with next edge. So same 30 degree, 60 degree inclination. Here also you can see the from this corner you can use protractor this corner as center and mark 60 degree inclination for same 30 mm. Okay, sorry 40. Same 40 mm. Afterwards, you can extend the projectors from these two corners. Say for an example, if it is AB, you can fix this, extend the projectors from the corner A as well as from the corner B. Okay, without any specific length, you just extend. Now you can take this, say for an example, AB, this one is considered as C. From this point C as center, what is the side of hexagon is 40 mm. Use 40 mm as radius, cut this projector. Okay, use 40 mm as radius and this corner as center, cut this projector. Similarly, and this corner as center and same 40 mm as radius, draw, cut this projector. Okay, after cutting these two projectors, it seems another two corners are fixed. Now you can join all these corners. Our hexagon is obtained. Okay, so we can name it as A, B, C, D, E, F. How we started is from the corner A, use protractor as the corner, 60 degree inclination with the same side 40, okay, 40 mm length, and B as center, use protractor, mark 60 degree inclination with 40 mm as the side length. Okay, then you fix C as center. Before that, you have to extend the projectors from vertical projectors from corner A and corner B. Afterwards, you can use C as center, this point C as center, draw an arc to cut the projector, and similarly F as center, cut the arc with a radius of 40 mm, cut this projector. With this two projector arc meeting point, we can fix another two corners as D and E. Then you can join the edges, complete the hexagon. Okay. Now we will move on to the problem. So read the question. Hexagonal lamina of 20 mm side rests on one of its corner on HP. Okay, corner on HP. The diagonal passing through the corner is inclined at 45 degree to HP. The corner passing through the corner is inclined at diagonal passing through the corner is inclined at 45 degree to HP. Then the lamina is then rotated through 90 degree. If the lamina is rotated through 90 degree such that top view of the diagonal is perpendicular to VP. Top view of diagonal is perpendicular to VP. For us, the next information is surface is still inclined at 45 degree to the HP. Draw the projections of lamina. So what we discussed in the previous pentagon problem, we can imagine the actual case. Corner is on HP means, so surface is on HP. If surface is on HP, in which view you can get the complete surface? You can all the corners are visible in which view? So if the surface is on HP, top view is completely visible. Okay, this is one idea. Another case, I told you, You check surface inclination. Surface inclination here also it is 45 degree to HP. In HP, top view will be projected on the HP as per first angle projection. So with that, I can assume in the top view, all the corners of the surface can be visible. Now we have to fix the position of the hexagon. We know that top view is full surface of hexagon. Okay. Now we have to fix the position of hexagon. So what they told us, corner is on HP. So this is the first quadrant. You can assume VP and HP. With this VP and HP, we can say this is the position of hexagon when corner is on HP. And as per first angle projection, we have to rotate this horizontal plane 90 degree in clockwise direction. At the same time, simultaneously, this surface also rotated through 90 degree. Now you can see clearly two sides of hexagon. This is one side of hexagon and another side of hexagon which is perpendicular to HP. After rotation of 90 degree in clockwise direction, these two sides will become parallel. Okay. Now you see, after the rotation of 90 degree in clockwise direction, this hexagon two sides will become parallel. So this is our position of the hexagon in the top view. This is our position of the hexagon in the top view. Now you can proceed for the problem because it is similar to previous case what we did for pentagon. First you draw the hexagon. So you know how to draw the hexagon with 60 degree inclination from the beginning base edge. So after completing the hexagon, what is the size of hexagon? It is lamina of 20 mm side. So you can fix that and give a name it as where you can start wherever you like. But being I fixed corner A as HP, so I started from there A B C D E F 20 mm as the side. Afterwards, you extend the projectors from all the corners. The procedure is similar to the pentagon problem. So extend all the corners. From this, I can complete the front view. Here, what are all the corners visible from the front view? See, there is an arrowhead at the bottom of the hexagon. So see here, there is a bottom of the hexagon. And this is the visible for front view. So A, B, C, D will be visible when I see from here. So I can keep F and E should be in the bracket because it is invisible from the front view. Okay. And A dash, correspondingly B dash is visible, F dash is invisible, C is visible, E dash is invisible, it should be represented in the bracket, then D dash. So our simple position of this problem is completed. Next we have to incline the surface. Surface inclination is with respect to HP. So surface is still inclined at 45 degree to the HP. You can draw a 45 degree inclination line anywhere on the XY without any specific length. Okay. Afterwards, what you have to do is you have to reproduce this simple position. What is the simple position? This is the simple position front view. Okay, this is the simple position front view. This has to be reproduced on this inclination line, inclination of 45 degree line. So I have to fix A dash because A is the corner which is lying on HP. So fix A dash on XY and measure the length of the simple position front view and reproduce the same on this 45 degree inclination line. Okay. Afterwards, also you can measure what is the distance between A dash, B dash, F dash, C dash, E dash with respect to any reference point. You can make measure the distance between A dash and B dash, F dash, and measure the distance from A dash. What is the C dash and E dash? Mark that. Then finally you can fix D dash. But the length of this front view is similar to the length of the step 2 front view, simple position front view. This is the simple position front view. Okay, this is the simple position front view. This length has to be reproduced with this inclination 45 degree line. Now you have to extend the projectors from this front view on the hexagon top view. Okay, you can extend this projectors from respective corners. Now see, I extended the projectors from here it is A dash. So here it is A. Both will meet at one point. I marked as A1. Okay, from this, next you can extend the projectors from D. It is our wish. We can start any projector. Okay, now F and E. extended the projector from F and E. And here also you can check in the A projector, D also located on the same projector. So extended the D. From front view D dash, I extended the projector. It is both meeting at this point. Mark it as D1. Afterwards, AD is completed. You can extend the projector of EF. After extending the projector of EF, from the front view, you have to extend the same. So where is E? Here it is E dash. Here it is F dash. Extend both the projectors. So I started with F dash. Correspondingly, you can mark point F1. In the same point, B dash also there. B dash and F dash lies on the same projector. So if you extend the projector, here it is point B in the hexagon top view. So correspondingly, both the F dash as well as B dash as well as B is meeting at this point, marked as B1. Now we left out is C dash and E dash. You can extend the projectors from C dash, E dash in the front view. Similarly, we can mark C1 and E1. Afterwards, you can complete the hexagon. Okay, join A1 B1 edge, then B1 C1 side, C1 D1 side, then D1 E1, E1 F1, F1 A1. Now the surface is inclined at 45 degree. The size of the hexagon is reduced because of inclination. Okay, you can check this top view. The size has been reduced due to the surface inclination of 45 degree. So in the previous two pentagon problems, we had an inclination with respect to VP because inclined to both the planes. Here they clearly told lamina is rotated through 90 degree. Okay, lamina is then rotated to 90 degree such that diagonal is perpendicular to the top view of the diagonal is perpendicular to the VP. Okay, so now we are going to rotate this lamina 90 degree by rotate this lamina by 90 degree. So if you are rotating by 90 degree means now the diagonal is A1 D1. This A1 D1 is now parallel to XY. If you rotate through 90 degree, this A1 D1 becomes perpendicular to XY. This is A1. Here it is D1. After rotation of 90 degree, it should become perpendicular to XY. So once again, we frame a rectangular box for our convenience. For our convenience, you see and draw the rectangular box. Okay, and you can give a name like 1 2 3 4 for that corners 1 2 3 and 4. Okay, now from the rectangle point of view also you can see 1 and 4 is parallel to xy. It has to be made perpendicular to xy because of 90 degree rotation. Okay, so first you draw the see now 1 and 2 is perpendicular in the 1 and 2 side is perpendicular in the xy. It is rotated through 90 degrees, so it becomes hence it becomes parallel to xy. Now you know that what shall we do in the next procedure. In between 1 to 2 I am having A1. In between 3 to 4 I am having D1. So this is the diagonal. A1 D1 is the diagonal. Now the diagonal is become perpendicular to the xy reference line. Okay. So correspondingly we can fix all the corners of hexagon in this rectangle. Complete the top view. A1 in between 1 and 2, B1 in between 2 and 3, and another point also is there, C1. So from this you have to measure from the top view. Step number 4, from the step number 4 you have to measure all the distances and converted it in the same rectangular box here. In between 3 and 4 I am having D1. In between 4 and 1, E1 and F1. Okay, now all the corners of hexagon is marked. Join all the sides A1 B1, B1 C1, C1 D1, D1 E1, E1 F1, F1 A1. Okay, so this position is completed. Now you have to extend the projectors. You have to extend the projectors from this top view, from this front view. Step number 3 and step number 3 and step number 5 has been extended the projector. Both the meeting point, respective meeting points, you can fix A1 dash B1 dash. Similarly, all the corners of hexagon. Okay, so we will start with B1 C1. Here I have B1 and C1. So here where it is B and C, you can check this point is B dash and this point is C dash. So you can extend the projectors from both the things. Okay. And one more option, uh, you can extend all the projectors of top view, then you can extend all the projectors of front view. Anyway, you can proceed. Only thing you have to mark the respective points. Okay. Being we discussed the same kind of procedure in the Pentagon 2 problems, I make it as I drawn all the projectors. For this also you can verify it. Okay, B dash, this is B1 dash C1 dash. You check B1 dash, here it is B1. Both are meeting at this point. That's why it's marked as B1 dash. Here it is point C in the front, C dash in the front view. Here it is C1 also lying on the same projector. It is C1 dash. In this projector, I am having diagonal A1, D1. I am having A1 dash on XY and D1 dash respective projector is meeting at this point. So it is D1 dash. Similarly, we completed all the corners are marked with the extension of projectors from this top view as well as from this front view. After marking all the corners, you can join the sides. Okay, D1 C1, C1 B1. You join all the corners. So all the corners are joined. This is our final answer of the problem. Okay. And one more thing you have to ensure, I repeated in the uh, Pentagon problem also. Here you have to ensure the position of hexagon as right whenever the corner is on HP, and being corner is on HP, that corner has to be made perpendicular to XY after the rotation of 90 degree. Okay. And you see the difference between H and 2H. Only the boundary related to hexagon or object outline related to hexagon is in thick line. All the remaining projectors, whatever we are extending for our purpose, including this rectangle, all should be in the thin line used by 2H. Okay. We will see one more problem with respect to the same kind of question, but in that question they have given question may be both corners touching on HP and VP. Check it. Let me. So these are the six positions of 6 steps of this particular problem. Okay, simple position to the required position by 3 stages. This question is an interesting one. Again, resting on HP such that one of its corner touches both HP and VP. So both HP and VP it is touching, but resting on HP. So read the next sentence. It makes 30 degree with HP, 60 degree with VP. Draw the projections by change of position method. Here, if you read this question, as we discussed in the previous cases, we have to understand the concept first. Resting on HP by corner. So corner has to be touched on both HP and VP. So first, being resting on HP, we have to fix the hexagon. Keep the hexagon by corner is touching on HP, similar to the previous problem. Okay, corner is touching on HP. If I rotate by 90 degree, two edges will be parallel to XY. So simple question is same. But in question point of view, here the surface inclination is not mentioned because it makes 30 degree with HP and 60 degree with VP. Okay, and we clearly identified resting on HP, the surface is on HP, so top view can be exposed all the visibility of all the corners in the top view. Surface inclination, which one you have to take, whether 30 degree with HP or 60 degree with VP. Okay, so you see resting on HP, you have to take the inclination in step number 3, 30 degree with HP. Afterwards, you can go for last final step, you can go for 60 degree with VP. Okay, so the similar to previous case, and draw the hexagon with a base side of 25 mm. Okay, so being a similar problem, I used the same length 20, so 20 mm side. With this resting on HP such that one of its corner touches both HP and VP. Okay, and corner on HP, now you see the two edges of hexagon is parallel to XY. In previous case, before rotation, two edges is perpendicular to XY. That is what we discussed in the first problem also. Now the procedures are common. Extend the projectors from all the corners. Fix draw the front view, and A, B, C, D is the visible corners, E and F is invisible corners, so it has to be represented in the bracket. Afterwards, now here you may have a doubt. It makes 30° with HP, 60° with VP. Being resting on HP, you have to take inclination with respect to HP. Okay, that is the surface inclination. So we, in the simple question, we assumed being resting on HP, we assumed surface is on HP. So surface is on HP means, even though in the sentence they may not mention the surface inclination, you have to take whatever the inclination given with respect to HP as surface inclination. So in that case, you can draw XY reference on the XY reference line anywhere. Draw 30° inclination line without any specific length. Okay, reproduce the same front view in the step 3. So reproduce the same front view by measuring all the respective corners. Okay, A dash, B dash, F dash, as well as C dash, E dash, D dash. Now you can extend. Now you can extend all the projectors. By extending all the projectors, you can fix draw step number 4, the top view, reduction in size. Okay, being the size has been reduced, now it will be clear for us. This is similar to the previous case. Step number 4 is differ from the previous problem. So what is the step number 4 difference? In the previous case, they have given diagonal is rotated through 90°. Okay, in this case, they said both the corners touches on HP. Same, if we are going to rotate again 90°, then only we can touch the corner on HP plane. So you can see, draw the rectangle. Okay, draw the rectangle for our convenience. It should be in thin line. After that, you can name it as 1, 2, 3, 4. Now I have to draw exactly on XY, because the data is both the corners, corners touches both HP and VP. Okay, so in the simple question itself, we drawn with the help of one corner of the hexagon is touching on HP. Okay, the same corner should touch the VP plane. Okay, that's why we fixed final position on XY, which means it is corner is touching on HP. Which corner? A1 is the corner. Okay, this corner, this is the corner touching on HP. The same corner has to be touched on the VP plane also. That's why it is drawn. A1 is fixed on the XY. Now you can complete the remaining corners with the help of the procedure what we known in the previous cases. So fix all the corners. Now you can complete the hexagon. Now the hexagon corner A1 is touching on the XY line. Okay, so simple question, we made corner touching on HP. Now with this we made corner touching on XY VP line. Okay, plane. Now you extend the projectors from step number 4 front view and step 5 top view. Fix all the points, join. Now you see both the front and top view is touching the XY reference line. With this we can say one corner A dash or A1 dash, A1 is touching both HP and VP. Similar to the previous case, only the small difference.